Hey students, this is lesson 1-5, exploring angle pairs. We're going to learn how to identify special angle pairs and use their relationships to find angle measures. Go ahead and do this review of some parts of angles and types of angles. All right, here's some key concepts. Look at the definitions carefully so that you can identify these. It's pretty important. So adjacent angles are two coplanar angles with a common side and a common vertex and no common interior points. Vertical angles, two angles whose sides are opposite rays. Complementary angles, two angles whose measures have a sum of 90. And supplementary angles, two angles whose measure have a sum of 180. Another type of supplementary line of supplementary angles is called a linear pair, and I'm going to give you this right now so that you can use it when we run into it. But a linear pair are two angles that make a line or a straight angle. So a linear pair is supplementary because they make a 180-degree angle. All right, so for number 10, supplementary angles are angles 3 and 6. Number 11, adjacent angles. There's actually two examples of those. 1 and 2 are adjacent, and so are 2 and 3. Vertical angles, an example of vertical angles is 2 and 5. And a set of complementary angles, two angles that add up to 90 degrees would be angles 1 and 2. All right, so let's use these. Using the diagram below, is each statement true? Explain. So angle PAL, look at that one, and angle LAM, that would be that one, are adjacent angles. Going back to the definition, to be adjacent angles, they need to be two coplanar angles with a common side, a common vertex, and no common interior points. So they have a common side, that's that A ray AL, they have a common vertex A, and they have no common interior points. So what they're saying there is any point inside this angle is not going to be a point inside that angle. All right, so that one is true. And because it meets the definition above of adjacent angles. Okay. All right, next one we're going to look at is PAO. That's that one. And NAM, that one. Are those vertical angles? To be vertical angles, we need two angles whose sides are opposite rays. So let's take a closer look at this. This is a ray here, and this is the opposite ray here. That one works. For this ray here, this is not an opposite ray because opposite rays create a line. So those two are not vertical angles. So we're going to say false. And we're going to say false because we don't have two sets of opposite rays. We should say no two sets of opposite rays. Okay, and the last one, PAO and NAO. So PAO, this one here, and NAO, this one here, are supplementary. To check that, we just have to add them up. 74 plus 106, and that equals 180, so we're going to say true. All right, I'm going to let you try that. Notice the typo there on 18, they wrote the wrong angle there, but the original angles we were looking at our vertical angles. All right. Making conclusions from a diagram. What can we conclude from the information in this diagram? Well, basically, just looking at how things are marked, we can conclude that angle 1 is congruent to angle 2, and that's by the markings. We can conclude other things also, like we can see that this angle and this angle, angle 3 and angle 5, are vertical angles. So we can conclude that. We can conclude that something like, and I'm just going to give one example, angle 3 and angle 4 make a linear pair, so they're supplementary. They're going to add up to 180 because they create a straight line. All right, I'm going to let you try that. All right, finding missing angle measures. It says that angle ABC and angle DBC are a linear pair. That means they make a straight line, or they add up to 180, however you want to look at that. Measure of angle ABC equals 3x plus 19, and the measure of angle DBC equals 7x minus 9. What are the measures of ABC and DBC? So let's write this first. The measure of angle ABC plus the measure of angle DBC equals the measure of angle ABD, and that's by the angle addition postulate. And then we get, by substituting in, we get 3x plus 19 plus 7x minus 9 equals 180. And there's actually two things. We're using substitution, of course, there, but also the fact that ABC and DBC are a linear pair gives us the 180. And let's say definition of a linear pair. Okay, and then we're just going to simplify this, and we're going to get 10x plus 10 equals 180. I'm just going to say simplifying there. And we're going to say 10x equals 170, and that's subtraction property of equality, and x equals 17. That is the division property of equality. And then to find the measure of angle ABC, of course, that's 3 times x plus 19, so we're going to take 3 times 17 plus 19 by substituting, and that gives us 70. Likewise, we can find the measure of angle DBC by doing 7 times 17 minus 9, and that's equal to 110. And if we add those two together, they equal 180, which means it all works because they're a linear pair. All right, I'm going to let you try that. All right, and the last problem, using an angle bisector. Remember, bisector means it splits something in 2 equal halves. So we can say that the measure angle JLN is equal to twice the measure of angle JLM. That's by definition of angle bisector. So that equals 2 times 42, which is 4. All right, I'm going to finish it up, and I'll see you tomorrow. You can check for the last answers. All right, that's the end of the video. Don't forget to do the lesson check because we're going to start by looking at that in class. See you tomorrow.